So let's say that we have an object that is moving in a circle. So it's on a table. So if we look at it from the perspective of above the table, it looks like that, and the object, let's say, is moving with a constant speed in a circle as a result of so here's the object here, and there's a string attached to it that makes it go in a circle, and the object is going with some speed v star. At every single point it has speed v star. It's going at a constant speed in a circle, so there's some tension T. This is a string. If we look at it from this perspective, edge on, there's the table, and the object is on the table, and the tension force is it can be that way or that way. It can be that way. It can be any direction in the plane, of course. It will be all sorts of different directions in the plane as the object goes around the circle. But from this perspective, we have the normal force acting on it and the gravitational force. And so the object, let's say, has mass m, and we can consider the work done by the different forces, the tension force, the normal force, and the force of gravity. And work is, by definition, the integral of the force over the distance. And so if we look at the object, it's moving in the direction of the velocity. So here, dr is pointing that way, and the tension force is that way. When the object is here, the tension force is that way. All right, the tension force is always toward the center of the circle, and the displacement dr is tangent to the circle. Not the best drawing, but we should be able to see that the tension force is always perpendicular to the infinitesimal displacement. So this, which is this in this case, is perpendicular to that, and therefore we're talking about the tension force times dr cosine, in all cases, the cosine of 90 degrees. So there's nothing to integrate over. This is 0 at every single point. But the same is true for the normal force and the force of gravity, because the object is moving in the plane. And so when the object is here, the normal force is straight up, and dr this way. So Fn dot dr is also 0 at every single point. And the same is true for gravity, because gravity is always straight down at every single point, but whereas the object is moving in a direction perpendicular to that force. So the object is moving in a direction perpendicular to all of these forces. So none of these forces do work, and so we could figure out that the total work is 0, but we could have figured that out from delta k side as well, which is the same speed. So 1/2 m v star squared. We call that the final kinetic energy minus the initial. Right? They're always the same, and so that's 0. And therefore, we could have gotten the total work from the delta k side as well. So this is this shows that circular motion is the result of a force, in this case, the tension force, that force that does 0 work. So what the force does is to change the velocity, but it doesn't change the magnitude of the velocity, it just changes the direction of the velocity.